Hey, hello everyone. Today we are going to see the phase 4 of the networking that is going on. And today I'm going to cover few concepts that revolve around gRPC, TCP, UDP, and the layer of awareness in for networking and DevOps and system design, and some practice tasks. Before that, let me answer a few questions. How big companies use gRPC internally? Before going through that, gRPC is originally developed by Google, and it came as a replacement for something called Thrift. Thrift is also basically an RPC based framework, but there are few issues with Thrift. It doesn't directly push and pull from the server. It takes some time. We don't have direct communication when it's needed for real time communication. Originally, these frameworks are developed for something called Borg, and now it is called Kubernetes K8s. We have 8 letters in between K and S. So, in case of Kubernetes, we need to have real time communication between different Docker containers that are there, and other workers that handle these. So mainly companies use these for real time communication like chat, streaming, and updates. Most widely, these are used for efficiency, low latency, no request needs to take time, and gRPC is originally preferred due to its strongly typed nature that goes good with languages like Go, Java, or Kotlin, and most widely we use it for microservices. We will cover that in a separate module. Basically, a microservice is a service for a larger application. Let's say I have an order app. I'll have a service related to queries. In this, it exclusively handles the request related to the queries. That's basically it for a microservice. So these are the things we use, and big companies use it for. Some companies like Google, Netflix, Dropbox use gRPC for real-time communication. So this is the first question, and when to use TCP versus UDP in your system designs. I think most of the videos are related to TCP and UDP. In TCP and UDP, I'll give you a small brief. TCP is connection oriented and UDP is connectionless, and UDP is connectionless. We'll wait for the connection to be established and data needs to be exchanged securely in TCP, and UDP we don't care about that. When you need delivery that needs to be guaranteed, let's say I am downloading a file, we need TCP. And for UDP, we don't use that because in UDP delivery isn't guaranteed. So when downloading anything, we'll definitely use TCP. And if the sequence matters, Let's say I have sent some money. I need the transaction to be sequenced. So in these cases, I'll prefer TCP instead of UDP. And if something I need in real time, let's say I'm going to video call some person and I need it in real time, I don't mind losing some data. So I'll go with UDP. And the last use cases in web apps, APIs, DBs, or file transfers, we'll use TCP. And in games, streaming, telemetry. In case if you don't know telemetry, telemetry is the data that is collected whenever you click a button. Every click, every interaction is recorded by telemetry. So these are the cases we use TCP and UDP in. And let's go to the next topic: gRPC versus REST API versus WebSocket. gRPC, REST, and socket. gRPC is preferred for microservices, and REST is preferred for simple applications or when it is related to legacy based systems. Only few legacy based systems support gRPC. We need additional configuration in these cases. And when you need fast and reliable communication, we are going to prefer sockets. And performance wise, gRPC is quite fast, REST is slow, and sockets are fast but only for few cases. They are dependent. And here we'll use HTTP2 for gRPC plus protocol buffs. And in REST, response request. In that, we'll use HTTP 1.1 and data is transferred via JSON. And in TCP, it is TCP for sockets. We'll just send the bits of data to the server. These are preferred for microservices, and these are for simple APIs and other applications, and these are for real time, strictly real time. These go with strongly typed languages. gRPC requires strong typing, and this goes with anything. And this goes for anything, but error handling is quite bad. And gRPC cannot be used directly in the browser. You need the console in your IDE. These two can be directly seen in the browser, and this sends binary data. That's our third question answered. And let's go to the fourth one, where layer awareness is important in DevOps and system design. So basically, this question answers the layers we have in the TCP/IP model. You can go through the phase 1 to phase 2 to see this. And let's go through some important layers that we need in DevOps: network layer, transport, and application. These are the layers that you can see in DevOps. and other layers are not quite visible or merged with this. When routing is important or firewalls, VPNs, we'll check the network layer things, and in transport we'll check load balancing. Load balancing is basically handling TCP UDP requests, port management, and latency issues. We'll check the transport layer in the DevOps or system design. Application layer will handle logic like TLS termination, because the termination needs to be handled from the application layer. Let's simply say logout. API gateways, when you want to strictly use REST to handle that, and Nginx for reverse proxying, I mean sending data requests and handling them. So based on these, you can check which layer needs to be used whenever you try to think about these. Now let's go through the practice tasks. Designing a system where some parts use TCP and some parts use UDP, and writing a sample network flow for a microservice system using gRPC for internal communication. I think we're going to do some work here. Okay, we need to design a system where some parts use TCP and some parts use UDP. So we have the cases with us, when to use something and when to not use something. Let's say I have a application, let's say a dating app, just to be relatable, and let's say you are a user, and you need to maybe map to different profiles based on your choices, and whenever you want to have a chat, there needs to be a one-on-one session between the matched persons, and whenever you two want to meet, let's say this app has real-time location, and before that I have an admin dashboard where I'll monitor these profiles. If something goes wrong, I'm going to dismiss a user, or I can check the reports on different users in this app. So let us check where we are going to use TCP here and where UDP is taken care. The first thing we are going to use is the matchmaking. In matchmaking, I don't want to lose some details about a person I'm going to meet. So I prefer TCP in that case. I don't go to UDP in this case. I want to find the real-time location of my match. We know that for real-time, I may lose some coordinates or something. I don't want to wait, so I prefer UDP in this case. And let's say I have an admin dashboard. Whereas admin dashboard, I need every data from the user. I don't want data loss. That's why I prefer TCP over UDP in this case. And we have a chat service. because this chat is not real time. I mean, this chat is real time, but we don't want to lose any data related to the chat that is going through. That's why I prefer TCP over UDP in this case. And let us add another service, analytics. What's your match rate? All those things. So analytics, I want to see real time. Every minute matters, and I may lose some data. So that's why I prefer UDP over this. I think a gaming server would be best idea to explain this. A very bad example. And let's go through task 2. Write a simple network flow for a microservice using gRPC for internal communication. Before writing that, let's take an example, e-commerce backend. And e-commerce backend, let's divide our services because we need to write protobufs for these. The very first thing I check in a e-commerce site is an order service, and after that inventory if the order is really available, and the best part, payment. And I need to keep you notified, notification service. These are the things we need in the e-commerce backend. So let's start writing the network flow. In network flow, first we write the order service. In order service, what we are going to do, we are going to check the inventory first whenever an order is placed, and if it is available, the order is placed. And after that, the order service can go through the payment service, and after the payment is reserved or successful. There's nothing called successful in e-commerce because these can be returned back. And payment service gets back to order service that payment is reserved. And if the order is cancelled, inventory is updated again and payment is reverted. And next step, if inventory needs to be updated, let's say the DB will push and pull for this service. And if we got confirmation, these are all triggered. And so for whatever changes we make, we are going to push the notification service. So using the order service as the point of contact, we are going to call these internal services in the network flow, and each of them will have their protocol buffs for the gRPC communication. And if possible, I'm going to make a coding video around this, explaining how the code works and how the system goes. Basically, the network flow diagram is just an implementation that we have in mind, but implementing this will take a significant amount of time. But this is a simple example where I am going to have a protocol buff for each of them with different set of functions and different set of parameters. You can go through the phase 3 video where I have explained the simple basics of gRPC, and if possible I'm going to make a full length application around this. And in the bonus I'm going to cover these topics, learn about a quick, and how it combines TCP, TLS, UDP ideas, gRPC web. This is basically going to be in React, and we can also convert the calls to REST style using the gRPC web, and other things like open telemetry, distributed tracing over gRPC service. These are related to the error handling and logging part in DevOps. Hope you like the video. Please like, share, and subscribe. Stay tuned for more updates. Thank you for viewing this video. I'm grateful to you all. See you again.